Hey everyone, I'm Tom Ballard, the Groundwater Guy. In this video, I thought I'd give a brief introduction to a continued hot topic in the groundwater industry, PFAS, what it is and its occurrence. Call it the Cliff's Notes version, if you will. So what are PFAS? And polyfluoroalkyl substances, PFAS for short, are a large class of human-made chemicals that have been widely used in various industrial and consumer products since the 1940s due to their water and stain-resistant properties. PFAS tend to be highly persistent in the environment, earning them the nickname forever chemicals, which you've probably heard, as they do not easily break down and can accumulate in time over water, so in water, soil, and living organisms. This persistence, along with their mobility in water, makes PFAS a significant and growing concern for groundwater contamination as they show up in more and more wells in the U.S. Seems like everywhere you look for it, you find PFAS. So what is the occurrence of PFAS in groundwater? PFAS typically enters groundwater through various pathways, primarily due to their widespread use and persistence in the environment. The main routes of PFAS contamination in groundwater include things like industrial discharges. PFAS are used in numerous industries, including those producing nonstick cookware, water-repellent fabrics, and firefighting foams. Industrial facilities that manufacture or use PFAS can release these chemicals into the environment through wastewater discharges, spills, or improper disposal of waste. These contaminants can then seep through the soil and reach groundwater aquifers. The other method is firefighting foam. This is a big one, AFFF, or AF3 for short. Aqueous firefighting foams, AFFF, commonly used for firefighting, especially at airports and military bases, are a significant source of PFAS contamination. When these foams are used during training exercises or emergency responses, PFAS can infiltrate the soil and migrate into groundwater. Military sites are often hotspots for this type of contamination due to the extensive use of AFFF. Landfills and waste sites. Landfills that receive PFAS-containing products like treated textiles, packaging materials, and so forth can leach these chemicals into surrounding soils and groundwater over time. Similarly, waste disposal sites for industrial waste or biosolids from wastewater treatment plants can contribute to PFAS migration into groundwater. Septic systems. Septic systems, particularly in rural areas, are another source of PFAS contamination. Human waste from septic systems can contain PFAS from consumer products like stain-resistant fabrics and nonstick cookware, which you probably don't think about as entering into your body, but it does when you think about it. So it's scary there, actually, when you think about it. These compounds then leach into shallow groundwater from the septic system. Studies have shown that septic systems may be particularly important sources of shorter chain PFAS compounds in private wells. Agricultural practices. The land application of biosolids, treated sewage sludge, for instance, or contaminated pesticides on agricultural land introduces PFAS to the soil. These chemicals can then infiltrate into groundwater over time. In some cases, pesticides themselves have been found to contain PFAS, further contributing to contamination in agricultural reasons. And finally, atmospheric deposition is another route. PFAS can also enter the environment through air emissions from industrial facilities. Once airborne, these chemicals can settle onto land or water bodies through precipitation and subsequently leach into groundwater. Studies have shown widespread detection of PFAS in groundwater across various regions. For example, in Wisconsin, PFAS were detected in 71% of shallow groundwater samples from private wells, with higher concentrations often found near agricultural lands or developed areas where waste application occurs. National estimates estimate that millions of people in the U.S. may rely on groundwater contaminated with PFAS for drinking water. And we are starting to find that no matter where you look for it, you seem to find PFAS in a lot of different wells. So it is out there, and we're finding more of it all the time. What are some of the health impacts of PFAS exposure? PFAS exposure has been linked to several adverse health effects. These include things like immune system effects. So you see reduced antibody responses to vaccines and increased risk of infections. Liver damage, changes in liver enzyme and potential liver toxicity. Cancer. Some studies suggest an increased risk of kidney and testicular cancers with long-term exposure to certain PFAS compounds like perfluorooctanoic acid, or PFOA, and perfluorooctane sulfonate, PFOS, and finally, reproductive issues, potential effects on fertility, pregnancy outcomes, and developmental delays in children. We've also seen, and in some areas where there's exposure to PFAS, things like ulcerative colitis and things like ulcers developing and perforations in the gastrointestinal system as a result of PFAS exposure. So there are definitely health effects, and this has really caused the EPA and state regulatory agencies to start looking at taking action on regulating these compounds and creating some regulatory standards for that. We'll get to that in just a minute. So given their persistence and bioaccumulation potential, even low levels of PFAS in drinking water can pose significant long-term health effects. What are the regulatory standards we're looking at here? And so the US EPA, Environmental Protection Agency, has proposed maximum contaminant levels, which are also abbreviated as MCL, so you hear that term. That is the abbreviation for maximum contaminant levels, which is a regulatory standard for what is the maximum allowed in drinking water. So they propose these standards for certain PFAS compounds. As of 2023, the EPA proposed an MCL of 4 nanograms per, that's an abbreviated NG/L. Often we use milligrams per liter or micrograms per liter. So nanograms per liter is actually fairly low, and that equates to parts per trillion. So these are some fairly low numbers here of what the EPA is going to allow to be in drinking water. So these standards are for PFOA and PFAS, two of the most studied PFAS compounds. And let me back up just a little bit to PFOS and PFOA as distinct from PFAS, which is the general category of PFAS compounds. There's a lot of abbreviations we're bandying around here, but some of these all fall under the general heading of PFAS, PFAS. Some states have adopted even stricter standards. As an example, Massachusetts has set a combined limit for 6 specific PFAS compounds at 20 nanograms per liter. So that's for 6 compounds. So that's a little bit more stringent than what the EPA is looking at there. So you can see the low levels we're looking at in the parts per trillion range. So what are our sources of contamination for PFAS? Key sources, we talked about this a little bit here, but the key sources in general categories related to PFAS contamination in groundwater include septic systems. Human waste from septic systems has been identified as a significant source of shorter chain PFAS compounds like perfluorobutanoic acid, PFBA, particularly in rural areas. Agricultural practices. The use of contaminated biosolids or pesticides on farmland can lead to elevated levels of PFAS in nearby groundwater sources. Urban areas. Groundwater near urbanized regions tends to show higher concentrations due to a higher level of industrial activities and wastewater discharge that you see in urban areas, of course. So we will see higher concentrations near urban areas. In conclusion, PFAS contamination in groundwater is a widespread issue with serious implications for human health due to their persistence and potential toxicity. Monitoring efforts are increasing as regulatory agencies like the EPA and state environmental departments establish guidelines to protect drinking water sources from these contaminants. However, more research is needed to fully understand the extent of contamination and develop effective remediation strategies. All right, so that is the show. That's the Cliff Notes version of PFAS. If you want more information, you can reach us on our website at sehydrogeology.com. That's our show for today, and thank you very much for listening. We'll catch you next time.